Hey guys, welcome to the 16th tutorial of data structures, and in this tutorial we are going to discuss about the second part of application of stack. And in application of stack we are going to see what is a function call. And first of all we are using the function concept in C++ programs, okay, and where a simple sample programs looks like it has a main function, open body and close body, and within which we will be having a function. For example, function open parenthesis, close parenthesis and semicolon. Okay, so this is a declaration of a function. If we are having a semicolon, then it is called as a declaration of a function, and this is called as function call. We are calling those functions. Okay, so when we are calling this function, it has a subprogram which run simultaneously, right? So a function, main function is also a function, and function fun is also a function. So this is called as a function within a function. This can also be called as a function within a function. So what happens is, the first executed function was main function. The second executed function was fun function, right? So but the first function to get completed is the last one to start it. Okay, so this acts in the way of last in first out, right? Or first in last out, right? So what happens is, it has a data flow in which the data flows from one loop to another loop. Okay, so for example, if this function 1 has a subprogram, okay, so this is the definition on body structure of the function, through which it has another function called as function 2, where this function will have another body by itself. So now, how the data flows is that it starts from main function, goes to the first function, but the main function doesn't get over yet. So the first function is being executed, okay, and the data flow goes from the main function to the function 1, and we can see that another function is available inside this function 1. So what happens is, again it opens the function 2, okay, so function within function within function. So first function, second function, and then third function. So finally, the last function declared or opened was completed as the first function to get over. Okay, so last function in is the first function out. Okay, so last in first out, which is a concept of stack. So this is how we are using the concept of stack in function call concept. Okay, so the first function gets completed, after which it comes to the function 1. Okay, so again the second function gets completed. Okay, the second function gets completed first, the last one, and then the previous one, and then finally the main function gets completed. Okay, so this is the concept of function call, which is a application of stack ADT. Okay, so a function within a function within a function, the first function, second function and third function. So third function gets over first, and then comes to the second function, and then comes to the first function. This is the main function. Okay, so first function in is the last function out, which is the concept of stack. Okay, so this is the concept of function call, and the next application is called as Tower of Hanoi. Tower of Hanoi. Tower of Hanoi is a very simple concept, okay, where we are having a bar-like structure. So let's assume this is one tower of Hanoi. Okay, so similar to this one, we are having 3 towers. So tower 1, tower 2 and tower 3. Okay, so tower 1, tower 2 and tower 3, which is like this. Tower 1. So we are having 3 similar towers like this one, where the bottom is being closed and the top is open. Okay, so any process of insertion or deletion is done through the top only, which is the concept of stack. Okay, so now what we are going to do is, we are having 3 particular disks, where the last disk is the largest one, okay, and then the next disk is the average disk, and then the topmost one is the smallest disk. Okay, now we have to let's assume this is tower A, tower B and tower C. Now we are going to replicate the same elements, the same disk in other tower. So let's assume we are going to replicate the process of A in C. Okay, but we have a single condition that always the smallest disk available has to be placed over the top. Okay, so that is done in 7 steps exactly. Okay, so that is how it's done is, so step 1. So first step, what happens is we are moving the smallest one to B and the average one to C. Okay, the smallest one to B and the tallest one, average one to C. So what happens is the largest one stays over here. Okay, and then the smallest one comes to B, and then the average one comes to C. So this is how it is being transferred. And in next step, step 2, so in step 2 what happens is, okay, we are now the condition has been satisfied. Now what I'm going to do is I'm going to take the small element, okay, take the small element and then place it over. So let's assume this is B. Okay, so let's assume this is B and this is C. Okay, now what I'm going to do is I'm going to take the smallest element from C and place it over B. So what happens is, A stays as it is, in C it gets empty and it goes over like this. Okay, so this is the next step. Okay, and now in the third step what we will be doing is, in step 3, okay, the largest disk is being taken and moved to the destination tower. Okay, from tower A we are moving it to destination tower C. Okay, watch carefully. So tower A becomes empty. Okay, and tower C has the huge disk. This is step 4. Okay, and then the next step, okay, the smallest element is come to the empty cell. This is the next step. Okay, and in step 5, okay, in step 5 what happens is the B's average disk comes to the C's second average disk. Okay, so the largest disk will be over here, this will be coming to this place, okay, and the smallest value stays in A itself. So now we are having C as the empty place. I'm sorry, this is C and this is B, right? This is C and this is B. Okay, so A, C, B. So far this is confirmed. Okay, in next step, okay, in next step what we are doing is, we are bringing back the smallest disk to the C. Okay, so initially what happened is, initially we had, so this is, we had A, B and C process. Okay, and this is your final stage. In final, all the elements are placed in C, and this is your start, where A, and this is your final stage. Okay, so by this concept we are using the applications of stack in Tower of Hanoi concept. Okay, so far we have seen 4 applications of stack, and the last application, infix to postfix, will be dealt with the next tutorial. Okay, so until we meet in the next tutorial, it's Karthikeyan signing off.